Hello everyone, this is Venugopal. Today in this session we are going to see the linked list concept from a Java collection framework. First of all, we will see what exactly this linked list is. So linked list is, you can say, linked list class implements list interface. It implements list interface. Second point is the linked list as a background it uses double linked list for storing elements. You can say that like the underlying data structure for this linked list class is what it uses a double or doubly linked list. Sorry, spelling is missed. Linked list. Here, as it is a part of list interface, we know that it contains duplicate objects, or you can say that elements. The next point is it also contains, or it also preserve, or is it also maintain the insertion order. Means the elements in which order you are entering, the output will be displayed in the same order. Next is, it is the best choice whenever you want to insert or delete the elements from the list. It will be a best choice for insertion or deletion from the list because no shifting is required. No shifting of elements will be required. That means what? For example, if you are having on a linked list like this, and suppose we are talking about a doubly linked list, then the structure will be like this, as it is a double linked list. The structure will be like this. So what happens if the first element is, if this will be the first node, so the first, this one will be the empty or null, and the address or the link of this node will be stored here. So this will be point to this node, and back this node will be point by this one. Similarly, this node contains the address of this one, and this will point back to, as it is a doubly linked list, so the structure will be like this, and at the end, if it is the last node, it will contain again the null. Now suppose if I want to insert any new node like this, if this is a new node, what I need to just do that? Only I need to break the chain. Suppose I want to insert as the second node, what I will do? I will break this link from here simply, and what I will do? I'll simply connect this to this, and this to this, and then you need to connect this to this one, and this will back connect to this one. So simply this node will be inserted here. That means what? There is no shifting of elements. You can directly insert the elements. In the similar manner, you can also delete the elements from the linked list directly. So that is what, whenever you want to do the insertion and deletion of the operations, right, the linked list will be the best choice. So whenever you want to insert or delete the elements from the list. Okay, the next point is like this can be used for list, stack, for the implementation of stack also, and queue. So linked list is majorly used for list or stack or queue. To create this kind of structure, you are going and you can use for linked list. The linked list is also, the class is a non-synchronized. It is a non-synchronized, just like your array list. Now the constructors for this linked list is, means how to create the objects of linked list. There are two ways. One is simply by using linked list LL and linked list LL equals to new linked list. This is the one way, and the second way is linked list LL equals to new linked list by passing the collection and the object of the collection. Wherever you want to assign this linked list with some other objects of the collections, then you can go for this syntax, next syntax. I hope you got this theoretical part. Let us move to the practical one. We will see some of the methods the linked list contain, how they are going to be executed or how they are going to be worked. So for this I am launching Eclipse. Just here we will create one new class. Again I will click on class. We'll give the name as linked list demo program. Include main method. It's taking little more time to launch this editor. So here the first thing, we would create the object of the linked list. We have already seen how. Click on this, Control 1, import, done. Now simply we will add some elements into this list. So ll dot add, by using it contains number of methods. Add, suppose I want to add first as a number, then ll dot add, then I want to add suppose my name, then ll dot again add suppose any another number 30, like that. So as it implements the list interface. So we know that list interface consisting of heterogeneous elements. So that is the reason why I am able to add integer as well as string data. Now just check out with the output. Now we will print this ll. We know that it will override the toString method. I have saved this program and I will try to execute this, run as Java application. See the order, 10 Venu 30. We are expecting the output should be in that order only. Yes, 10 Venu and 30. As we have already discussed, the insertion order is reserved, right? And also it contains the heterogeneous elements. I have missed that point in my theoretical description here, but you please add that the heterogeneous elements is also it contains. Now you know that how to restrict. We have seen if you want only integer, you can put here the wrapper classes. Now here, suppose I want a particular location, ll dot add, for example, in front of this Venu I want one more name, for example another name. Suppose I want to add Gopal. Okay, so where I want to add this one, I want to add at the second index, so I need to give 1 comma that Gopal. Okay, so if we'll execute this one, see the output, it should get the output like 10 Gopal, Venu and 30. So see the insertion, already we have seen the diagrammatically how the things will be executed in the background. Okay, so you can add at any of the index wherever you want to insert a new element. Now here by using this ll dot, suppose I want to the element at the first location. So inbuilt we are having some methods like add first. Suppose I want to add at the beginning some element. For example, in the beginning I want some name Narsingoju. Can I do that? Absolutely you can. How to do that? We have seen there are some inbuilt methods in this collection. Now I will print here just to check. Run as Java application. See, with this method ll.add first, we are able to add the elements at the beginning of your linked list. Similarly, if you want to add at last, ll.add last. Suppose you want to add something in the last, for example, I am added last. Just check it out. Control S. See, I am added at last. We have added into the linked list. Likewise, you can also remove the elements. If I'll do ll dot remove, so to remove the elements we have number of options here. Either you can provide an index which element you want to remove, which is present on the given index, or you can directly remove like this also, remove all or remove first, remove last, etc. Suppose first of all we will try to remove by giving an index name. Remove the bracket, we will remove the first element, that means 0 and 1. The second element will get removed. We'll copy this and let us print here. Control S, run as Java application. See which one is the second element? 10 was there, but after this removal operation it gets deleted from the linked list. You can also remove by stating directly like remove last. Suppose ll dot remove last or first. Suppose this one we will call, right? After that we will print system.out.println linked list object. Control S, click on run as, execute it. You will get, see, the last element was I am added at the last, it has been deleted. Likewise, you can go and perform the other methods also. I hope you have got the idea of what exactly mean by linked list. We have seen the features when we need to use the linked list, what is the best choice, and the details regarding the linked list. We have seen what are the various constructors to declare the linked list, that also we have covered, and finally we have seen the practical example. I hope you have understood. So we will meet with some of other videos in my coming sessions. Until then, bye bye.